Guys, this is Mrs. Bolin here with your 8.1 review notes and answers to the odd numbered questions in the homework assignment. So first I'm going to start off with the warm-up. So we have a graph and we're told to use it to solve. This is the easiest type of problem because all you have to do is look for the point where the two lines cross. Okay, then we need to write the ordered pair for that. So in the x direction, I didn't go to the right or to the left. I just stayed right in the middle. So I'm going to put a 0. And then in the y direction, make sure you guys know x is side to side, y is up and down, and they go alphabetically. In the y direction, I went up by 2. So that is my final answer. All we had to do was count. Super easy. All right, question number 2, solve by graphing. These ones are a little bit harder to solve by graphing because they're written in standard form, not slope-intercept form. So we need to use the cover-up method, which really mathematically is just plugging 0 in for the opposite letter, because where the x-intercept is, the y value is 0. So if I put 0 in for y, I would get negative 2x equals 4. So I'm going to write that out. Negative 2x equals 4. And then I'm going to divide by negative 2 on both sides to get x equals negative 2. So I'm going to go ahead and put that point right there. I'm going to put a little purple dot here so that you know I'm doing all that work for that one in purple. And then if I put a 0 in for x and cover that part up with my big sausage fingers, we get 4y equals 4. So 4y equals 4. And then I'm going to divide by 4 on both sides. So I get y equals 1. So I'm going to put a dot at y equals 1. And then I'm going to kind of follow that pattern just to extend it to get a few more points because I'm not super good at drawing straight lines. All right, so now I'm going to switch on over to a different color just so you guys can kind of tell there. So now I'm going to use green for this one. Again, cover-up method because it's in standard form. If I put a 0 in for y, that part essentially goes away because anything that is being multiplied by 0 makes 0. And if I'm subtracting 0, it doesn't change the value. Okay, so I'm going to write 3y equals 9. Sorry, x. I don't know why I wrote y. 3x equals 9. Sorry, that was a big funky x there. Divide by 3. So x is equal to 3. So on the x-axis, I'm going to find positive 3. And then I'm going to do the same thing for y. So I have negative 6y equals 9. Divide by negative 6 on both sides. So y equals negative 1 with 3 left over. So negative 1.5. So I'm going to go to negative 1.5. And so then I'm going to go down another 1.5 and over 3. 1, 2, 3. Oh, this isn't going to quite cross. What is this one going? So this is going up 1, 2, 3 and over 1, 2, 3, 4, 5, 6. So I think these ones are parallel. Looks like it, you guys. So if they are parallel, that means that they never intersect. I should have looked at these problems first before I started talking. Anyways, this is what happens when you're doing the work together anyways. So you should be noticing like, there's something odd about these. I don't think they are going to cross. So if they never cross, if they're parallel, you would write that there is no solution. There is no value that will make both of those equations equal to each other. Okay, so the next one is super easy compared to this. Graph y equals 2. So look, you guys, here's y. Here's where y is equal to 2. And then if y is always equal to 2, that line right there represents all of the values for x where y is equal to 2. Okay, no matter what x is, y is always going to be equal to 2. And so that's the graph for that. Then this one, if x equals 2, I'm going to find x equals 2 on the x-axis. And then if that value of x is always 2, that is the line that represents when that is true. Okay, so now we're going to do some practice problems where we see if an ordered pair is a solution to a system. Remember that we take the values and we plug them in for x and y and we see if they're true. So I'm going to put in the 3 in this equation right here. Instead of writing x, I'm going to write 3. And instead of writing y, I'm going to write 1. And then I'm going to put equals 4. And I want to see if that's true. So I'm going to go 3 plus 1. Well, that's 4. 4 is equal to 4. That's true. So it worked in the first equation. Well, now I just need to check it in the second equation. Okay, so I'm going to take this equation right here. I'm going to plug in x and y. Instead of writing the x and y, I'm going to put a 3 and a 1. So let's write that out. So 2, instead of x, we're going to put in a 3. Take away y. Instead of y, we're going to write the 1 there. And then this one should be equal to 3. So we're going to see if that's true. 2 times 3 is 6. And I want to see if that's correct. 6 take away 1 is 5. 5 equals 3. That is not true. So this one is no, it is not a solution to the system. It was for the first equation, but in order for it to be a solution to the system, it has to be it for both equations. Okay, so now I'm going to do the same thing with this problem. Okay, this is x, this is y. I'm going to plug it in. So x is 1, y is 3, and I want to see, does this equal -2? 1 take away 3 is -2, and that does equal -2. All right, so let's work on the second one together. You guys should be, by the way, you guys should be pausing the video, trying it on your own, and then seeing if you're getting your answers right, okay? So don't just copy all the answers. See if you can do it correctly, and then use the video to check and correct if you need to. Okay, so for the next one here, I'm going to write 2 instead of x. I'm going to put in the 1. I'm going to copy the plus. Instead of y, I'm going to put in a 3, and then I'm going to say equals 5. So 2 times 1 is 2. 2 plus 3 is 5, and 5 does equal 5. That is correct. So because it works for both equations, yes, this is a solution to the system, okay? So moving on down to problems 3 and 4, where we're going to solve by graphing. Number 3 is super easy because it's in y equals mx plus b form. So remember, the b is where we begin, always on the y-axis. So I'm going to put a little blue dot by this one to let you know that I'm graphing that one in blue. So 1, 2, 3 is where I begin. And then the slope would be -1. Anytime there's not a number, we can just put a 1 there. And then we can also turn it into a fraction by putting a 1 underneath. So because it's negative, we go down by 1 over 1. We always go left to right like we're reading a book. Unless we want to do the pattern backwards, instead of down, we can go up by 1, but then we would have to go backwards by 1. So we can do the opposite of both of those to get more points if we want to. Okay, that's the first one. The second one, I'm going to put a little green dot. And then again, there's no number in front of the x, so I could put 1 over 1, but this one's positive. I'm going to start at the 5. That's where I begin, and then I go up 1 over 1, and then I just ran out of room, so I'm going to go down 1 and backwards 1 to get a few points. And remember, we have not answered the question yet. The answer to the question is the point where they cross. Okay, so I'm going to write the ordered pair for that. That would be -1 in the x direction, and then +4 in the y direction. All right, problem number 4 is a little bit more challenging because it's written in standard form. So we have to find the x and y intercepts with the cover-up method. Okay, so if I cover up or put in 0 for y, that part goes away. So I have 3x equals 6, so that's what I'm going to write. 3x equals 6, divide by 3. So x is equal to 2. So I'm going to put a dot right there. Remember, here's x. X is equal to 2 at that point. And then I'm going to do the same thing for the y. So I'm going to cover up the 3x right there because I'm putting in 0. So essentially what I have left is -2y is equal to 6. I'm going to divide by -2 on both sides. So y equals -3. So I'm going to put a dot on the y-axis at -3. And I'm going to connect those 2 dots. Whoa, that's kind of a wavy line. Sorry about that. Try to make it straight on yours. Okay, and so then I'm going to graph the other equation. This one was in green. I'm going to do the next one in blue. And I'm going to find y equals -3, which is right there. And then the line that passes through the y-axis at 3, where y is always equal to, -3, where y is always equal to -3 is this horizontal line right here, okay? So again, I haven't answered it yet. The answer is this point where they cross. So in the x direction, we went 0. We didn't go left or right, but in the y direction, I went down by 3. And that's our answer. Okay, now I'm going to go over the answers to the odd numbered questions for your homework assignment. So make sure that you guys are trying the problem first and then using the video to check your answers and copy the correct work. Then use that information to help you on the even ones, okay? So it's really, really important that you guys do the correct work, not just get the correct answers, although that's important too. If you have a whole bunch of work and you get all the wrong answers, you're going to lose a bunch of points, okay? So make sure that you have the work and you're doing it correctly, okay? So for these ones, we're just telling whether it's a solution to the system. So remember, we're just going to plug in x and y. So I'm going to start with this first one. For y, I know the value is 0. So I'm going to put 0 equals, I know the value for x is 2. So I'm going to write 2 minus, oops, sorry, I'm like a step ahead in my brain. And my brain's going a lot faster than my mouth and my hand. So 0 equals 2 minus 2, which is 0. So that is true. Now I'm going to plug into the other equation. It has to work for both equations. Okay, so I know y is equal to 0. Negative 3 times x plus 6. So I know 0 is equal to negative 6 plus 6. Well, 0 equals 0, so that's true. So yes, okay, yes, this is a solution to the system of linear equations. But make sure you have the work. You have to plug the values into both equations, and you have to show that it's true, okay? All right, question number 2, or just kidding. Skipping number 2. Remember, this one is x, this one is y. Plug it in and see if it works in both equations. All right, we're going to do question number 3 real quick. This is x, this is y. I'm going to plug in the x for that x and the y for that y to start, and then we're going to do the same thing with the other equation. Okay, so I have 3, and then I'm going to, instead of writing x, I'm going to look and see what x is equal to, which is negative 2. Make sure you use the parentheses here because anytime a number is stuck to a letter, it means multiply, okay? Then I'm going to copy the minus 2 from here, and then for y, I'm going to plug in a 3, and then I'm going to see, does that equal negative 12? Okay, so I'm going to go, well, 3 times negative 2 is negative 6. Negative 2 times 3 is negative 6. Negative 6 and negative 6 make negative 12. And that is indeed equal to negative 12. So I've checked the first one. Now I have to do it for the second one. Okay, so we gotta check yourself before you wreck yourself, right? That's like the kind of music that I listened to when I was in high school. That was like a million years ago. All right, so we're gonna plug in x right there for x. We're gonna plug in y right there for y. So I'm gonna write this out. 2 times negative 2 plus 4 times 3 equals 9. Is that true? Yes or no? 2 times negative 2 is negative 4. 4 times 3 is 12. And I want to know if that's equal to 9. Well, I get 8 on this side. That is not true. 8 does not equal 9. So I would write, no, this ordered pair is not a solution to the system because it only worked in one of them. It has to work in both in order for it to be a solution. Okay, we're going to skip number 4 because that's an even problem, but the way that you would do it is just like how we're going to do number 5. These ones already have the graphs for us, so we don't even have to do any work, you guys, except for counting. So remember, the solution is this point where they cross, where the two lines intersect, and because that's the point that works for both of those lines. So we just need to write the coordinates for it. In the x direction, we went backwards 1, so negative 1. In the y direction, we went down by 3, so negative 3, and that's it, you guys. Okay, you should be able to do 4 and 6. You could even ignore those equations right there. Just look for the point where they intersect and write the ordered pairs for that. Okay, question number 7. Okay, now we actually have to do a little bit of work. We're going to graph those together. So I'm going to start with this top one. Remember, this is where I begin at positive 2. And then I'm going to go up 1 over 2, up 1 over 2, because that is how I move. That's what the M stands for. It technically stands for slope, but you're like, what letter should we use for slope? How about M? Yeah, I don't know. Yo no sé, pero yo no sé nada. So we're going to go ahead and cross or connect the dots. Okay, so that's our first line. And then we're going to do the second line. Okay, so I'm going to do that one in blue. Again, this is where we begin at +4. And then we're going to go down by 1 over by 2, because remember when there's a negative there, that means that we're going to go down. So -1 and then over 2, down 1 over 2. And I can go up 1 backwards 2 if I want to do the opposite to get some more points there. And then I'm going to connect the dots. Okay, and I'm not done yet because I have to put the point where they cross. All right, so the point where they cross would be in the x direction. We went over by +2, and then we went up by +3. So that is the answer. We're going to skip number 8, but I know y'all can do it. So remember, if there's no number at the end, you can always write a 0. So this one would begin at 0 and then up 4 over 1. Remember, if it's not a fraction, you can always make it over 1. So you guys do that one on your own. We're going to look at number 9 together. So for number 9, this is another one in slope-intercept form. So we begin at +3. So I'm going to put a little blue dot by this one. So up by 3, put a dot, and then up 1 over 1, 2, 3, 4. I'm going to extend it backwards 2 by going down 1 and backwards 4. 1, 2, 3, 4. If your points all make a straight line, you know you did it correctly. Well, mine's not really that straight. It's kind of wavy a little bit, but if I had a ruler, they would all go through. Okay, and then the last one here that we're going to do together is right here. We're going to begin at 5, and we're going to go up 3 over 4. But look, I'm off my graph already. So what I'm going to do is I'm going to do the opposite of both of these. I'm going to go down by 3, 1, 2, 3, and then I'm going to go backwards 4. 1, 2, 3, 4. Okay, because if I went this way, up by 3, 1, 2, 3, and over 1, 2, 3, 4, that would be off of my graph, a little bit harder to connect through. But what's really important is this point right there, because that's the point where they intersect, and that's the answer to our system of equations. Okay, so I'm going to do the ordered pair for that, which would be backwards 4 in the x direction. So we just say -4 when we go to the left. And then I went up by 2, so I'm going to do +2, and that is my answer. Make sure you fill in the work for the rest of the problems. Make sure you upload your answers to Canvas. Take a picture so that we can see all of your beautiful work. And thank you very much for paying attention, and I will see you guys next time.